Introduction of what I am talking about today. My name is Uday Shivaswamy. I am a program manager in the Windows division. I work on app and device compatibility. So let me give you a brief introduction of what our team does, essentially. We are a group of about 100 engineers. We basically work with all the other Windows teams to make sure that compatibility is baked into the design of Windows. We also build a lot of features. Some of you might have heard of them. We enable compatibility scenarios. If you've ever used compatibility modes in Windows, you know that comes from our team. You might also have heard of things like the Windows 7 Compatibility Center. It's one of the busiest Windows Online websites. We do that as well. So it kind of gives you an idea of what the context of my discussion today is. Essentially, I'm talking about the critical message that compatibility is important to our mutual customers, and how you as developers play a very crucial role in making sure that our mutual customers' ongoing investments continue on. So let me start with a little bit of the agenda for what I'm going to talk about today and what you can take away from that. So first, I'm going to talk about what are the big decisions that we did in Windows 8 that will impact today's existing apps. That means that mostly you're talking about desktop apps. Next, I'm going to talk about some compatibility practices for desktop apps as well. And these are things that we've gathered over time through various failure detection mechanisms and investigations. And finally, I'm going to close it out by talking about some of the compatibility features that we've built for Metro-style apps. And these you can take advantage of now so that you can build great apps for the future. What are you going to leave the talk with? Essentially, you want to be able to understand what are the things you need to be aware of for desktop apps, how you can certify them and get them on the store when the store becomes available for listing. And finally, how do you assess, verify, and make sure your Metro-style app can also be successfully verified for the Windows Store. So with that in mind, let me take a step back and kind of talk about this a little bit. Why is compatibility even important? Many of you, I'm sure, if you're in an enterprise, you understand this very well. However, if you are an ISV or a developer, most people feel the first instinct is a new operating system comes out, so this is potentially a new revenue stream for me, meaning I have a new version of it. But if you look at it from our consumers or business perspective, their key takeaway, their key mechanism of how they preserve their investment is that they choose the apps that continue to work even beyond the OS release. The reason why is that, remember that they choose the operating system, new ones, when it comes out, because it provides new value for them. Similarly, they expect that they buy apps when it provides new value for them as well. So they would prefer to buy it when there are new scenarios that apps enable, for example. Look at it from your perspective as a developer. One of the things that you do if you build apps with compatibility by design principles is essentially it'll reduce your code churn, potential lowering of engineering costs in terms of reduced bugs, and of course, faster time to market, whether it's your enterprise customer or whether it's some retail shop that you're selling your app through. So either way, you have really much better time to market compared to your competitors. So that's kind of the background that I'm going to talk about and some of the things that we're going to jump into now. The first section that I'm going to talk about today is about things that impact compatibility. So you might feel that this is different. This is a different message from what our keynotes and big pictures have thought about. But I want to make sure that I want to tell you that I'm not trying to contradict anything. So let's start with this. You've probably seen this slide about 20 different times already. And I want to make sure that this message goes through clearly. If an app or device runs on Windows 7, it will run on Windows 8. Right? So you've heard of this statement, but you probably haven't heard of how it is that we actually make this happen. How can I stand up here and make this statement like this? So let me kind of give you a little bit of a background. And that basically is that essentially our team does this in 3 deliberate ways. We bake compatibility into the operating system instead of simply reacting to broken apps when we find them. So, for example, first of all, compatibility is a key tenet for every design in Windows. That means if any changes that we plan to do in Windows, any big changes that we do, for example, design changes for Metro-style apps that we have done across Windows, all of them have considered compatibility as a factor in all the design changes that they've done. Meaning, even though they're making radical changes to Windows, making sure that existing apps continue to work is one of the key design goal criteria, for example. That is one. And we provide we, as our team, the app and device compatibility team, provide the value, the knowledge, and the background around compatibility for that. Next, obviously, we work with telemetry. All of you got a build. There's a lot of compatibility detectors that detect compatibility failures for all the apps that you run. We collect all of the data, mine that, find out if we are finding new issues, and before we release it, we fix them and go make further design changes if we need to. That's another way. And third, we test. You won't believe how much we test. We have, I'll tell you numbers later on. There are thousands of apps that we test, automated tests that run on every Windows build that comes out. I don't mean externally, but even internally released builds are tested heavily from that perspective. Obviously, that way we catch a whole bunch of failures as well that we catch up front so that you don't get to experience the badness of all the apps that fail. Next, we do make changes, obviously. We need to move the platform forward. But when we do those kind of things, we build mitigations into the operating system. And that's one of the things that you would have probably seen are some of the compat modes. So the type of mitigations that we do are 2 types. One is a class mitigation. That means that we know that anybody who uses a certain component, any existing app that uses a certain component in Windows will probably break. So those kind of things, the component and us will provide a generic mitigation so that any existing app that calls into that component will automatically get the mitigation so you don't have to worry about it. That means that the existing app will continue to work in Windows 8, but in a compatibility mode of some sort. And then there are some which are things where there are unique failures to certain apps, which are not really a class kind of an issue. So these apps will probably get individual fixes. But there is one class of apps that we obviously work with ISVs on a regular basis, and most of these are antivirus, firewall, and really low-level apps. And for them, they need to really know what's happening in the kernel services that change, and they work with us right from the beginning of the development and come up with newer versions of their software. Okay, now I've talked about all kinds of efforts that we do internally. But now, that doesn't mean, okay, compatibility, everything's fine, nothing to do from your perspective, let's go home. But what I'm trying to say is, some of the big decisions that we've made, even though we have done a lot of mitigations for the existing apps, as a developer, you need to be concerned and you need to be aware of these kind of changes so that when you are working on your next set of apps, it is important that you make sure that you can run on those kind of things. Today, I'm going to talk about 4 of these things. Let me put these in context. These are all changes that impact desktop apps. Obviously, Metro-style apps, they're all new, and they already have these changes in place for them. And these are the things that you need to be aware of as we move forward. The first one, obviously, we changed the OS version. And that has an impact just by itself. It's a very small change, but it has a huge impact. Next, we have some changes in the desktop window manager. I'm going to talk more about that as to why we did that. Again, third one is startup apps. Startup apps have a big impact on battery life. You already saw a demo in the keynote for that one. And finally, we're going to talk about .NET 3.5, some of the changes we did there. So I'm going to pose a question, but not ask you to actually reply back, because I'm pretty sure many of you are very familiar and can positively answer yes to this one, probably. So this is a very, very small change. So we obviously changed the OS version number. And we learned from Windows 7. One of the things that we learned was if we change only the minor version of Windows, the impact of the problem is significantly lower than changing the major version. So Windows 7 was 6.1. We use the same logic in Windows 8. Windows 8 is 6.2. So yes, we reduce the scope of the problem in a big way because of this. But that doesn't mean the problem went away, unfortunately. It is a very small change, right? I'm going to talk about, we do need to make this change because our Windows needs it from a lot of update services and various other services that we use ourselves. And there are other genuine requirements for needing this change. But the fundamental problem there is that most apps do it from checking the OS version and blocking themselves from installing or running. I'll give you some numbers here as to how big this problem is. The change is so small, but the problem is, as soon as we did this change very early in Windows 8, 400 and something apps failed immediately, either to install or either to run. And these 400 apps are out of the 6,000 that we test. That is 7% of the entire market was failing. And these are 6,000 top apps as mined by telemetry. These are not any apps that we randomly pick. These are the top apps that are selling in the market that are being used. 7% of the market would immediately fail. Windows 7 with just this one change. That's how big the impact of this change is. So really think about, do you really need to make this change? Do you really need to do the OS version check? If you do, don't block the app. That's the key thing that you have to think about. If you don't want to support your app, make sure you let the users know that you don't want to support it, but don't block it from installing. Because one thing, Windows provides compatibility modes which users will immediately try to override it, which might defeat the purpose of what you're trying to do. And it is just a huge customer pain point. One of the things that every time we go through any compatibility workshop with enterprises, that's one of the first things that they ask: how many apps will block themselves? What is my scope of the problem when I'm trying to move from, say, XP to Win7 or Vista to Win7 or something like that? So, and another key thing that I want to point out is the last bullet there. A lot of apps do check file versions, check OS version through registry services, various other obtuse ways. All of that just basically hinders and puts the barrier up even higher and higher. So you have to be cognizant of making sure that these are things that your customers feel really painful about. So, in closing this particular topic, I'm going to just say that all of the 400 apps that we found, there is no single fix that we can put on them because every app does it in a different way. So essentially, every app needs to be fixed individually. That means unique solutions for all of them in Windows. It doesn't mean that these apps just failed. We do go back and fix every one of them, but we have to fix them one at a time. So that's the scope of the problem and kind of gives you an idea of what you need to handle, both from Windows perspective as well as your customer's perspective. All right, let's talk about Desktop Window Manager. One of the things that is very crucial for pretty much everything Metro Style design, Metro Style user experience, Metro Style the WinRT APIs, a lot of them related to display are all dependent on DWM. DWM is a critical component for the entire Metro Style experience in Windows 8. That means that having it on all the time is very, very, very important, obviously. And that means, let me explain this in a different way. What does it actually mean? What does DWM always on mean? It means two things, essentially. There's an API in Windows 7 called DWM Enable Composition. And that would allow you to basically automatically programmatically turn it off if your app didn't need it. Today in Windows 8, that API will just return SOK and say, OK, I turned it off, but it doesn't really turn off. So it's essentially disabled. So the API doesn't do anything. That means that if you have an app that actually calls that API to disable it, you have to potentially rethink why you need to disable it. That doesn't mean that your app is broken. I want to make sure that this change doesn't mean that existing apps will break because of this change. Existing apps will have mitigations put to them so that they will continue to work. But as a developer, you need to think about, do you need to turn off DWM? Because turning off DWM has a significantly adverse impact on the system now than it was in Windows 7 or Vista. And the second one, think about DirectX. If you're a gamer and write a lot of gaming applications, then this is something that might impact you as well. Think about a scenario where you have DirectX and call into GDI, like even if you do open file from a DirectX app using GDI calls. These kind of things can actually mess it up, meaning mixing DirectX when you're mixing GDI calls into your DirectX app, that one corner scenario is the one that really has an impact. So you can potentially have degraded performance on those kind of things. But if you're using DirectX 8, 9, 10, 11, then those are pretty much mitigated in good ways. 10 and 11 know how to handle DWM automatically. 8 and 9 have a lot of mitigations built in. But from a game developer perspective, you really have to rethink, do you really need to use GDI APIs from your DirectX app? That's the key thing. There's a third impact to this one, which is high-speed recording apps. These are corner cases. Not many apps do this. If you take a regular screenshot or regular picture or things like that, you're not going to be impacted by this at all. Most apps don't do that, don't do any high-speed recording. So if you're writing directly to the device context buffer and doing high-speed recording or read writes, things like that, those are the kind of places where DWM can have an impact. Because in Windows 7, when an app tried to do those kind of things, DWM would just back away because they knew the app had full context of about what the device is, or it knew exactly how DirectX was handling, things like that, so it would back away. Now it cannot back away. Because of that, you can have degraded performance on those things. And finally, this is a change that's been a while in the making. So low color modes are basically emulated. That means if you do have 8 and 16-bit color, you'd be surprised to find that we still have a lot of popular apps that use 8 and 16-bit color, and they are now going to be emulated. That means that there is no native 8 and 16-bit color. They're all 32-bit color. All right? So I'll give you a brief demo of what it looks like. So I'm going to start up a really fun app, Flight Simulator 2002. I'm sure many of you have played this. As you can see, this app in a windowed mode works like a champ. This particular screen that you're seeing, this is actually, by the way, a DirectX 7 app. It's written in DirectX 7. But this whole menu that it's written, it uses a window. It uses a lot of GDI in there. So in the windowed way, it works like a champ. But I go into full screen mode, this is what you'll end up with. But I'm just giving this to you as an example of what happens. But that doesn't mean this app actually will fail, because we're working on making sure that the app works. So this is still in progress. But let me show you that if you use pure DirectX 7 and you run the app, I'm going around trying to play a lot of things. I'll show you. So this is in windowed mode. I can go play. I can do all kinds of stuff. And I get into full screen mode, exclusive mode. App works like a champ. Please. Oh, there you go. I think the resolution was the issue there. So yeah, the app works fine when you're in full screen DX mode without actually mixing up GDI and DirectX. If you're doing that, that's the only thing you need to be concerned about a little bit and rethink whether you need to do it in that way. Let me get out of this. But I want to assure you that this app won't fail. If you're if this is one of your favorite games, it'll work later on. Anyway, let's get back to the slides. All right. With that, let's close out talking about DWM a little bit. So primarily, what do you need to be? Let me go back and talk about this. Primarily, what do you need to be concerned about? If you're writing directly to the device context, That is one area that you need to think about. If you have low color modes, I think it's been a decade now. So it's time to move on to 32-bit, I guess. And using DirectX 10, 11, which are natively supported in Windows 8, is probably the best thing from a GIM app perspective. So this gives you a context around the changes. And I want to assure you that if you're a windowed app, or if you're a .NET app that doesn't turn off DWM, or a Silverlight or a WPF app or any of those kind of things, you will have absolutely no impact for all practical purposes. So this whole thing, while it sounds like it's a big issue, it is a pretty narrow issue for a narrow set of developers. So that's the way to think about it. Let's move on. Let's talk about startup apps. I'm sure many of you have startup apps for a reason. A lot of ISVs, OEMs, and various other enterprises have startup apps because they do provide real value, because they feel that they can provide value when the user needs it during the scenario that that particular user is going through. However, even though no single app actually has any impact in a significant way, the problem is when you end up with a lot of them trying to do the same thing at the same time, whether it's during boot up, or whether when the user first logs on, or whether when the user just gets focus of what they're trying to do the first time. So what happens at that point is all of the apps try to contend for the resources, whether it's memory or CPU or disk I/O or whatever be the case. They all try to contend and try to provide the value that they are trying to provide. And that means that the system bogs down in a significant way. And remember, startup apps will continue to run even if the user is completely in the Metro apps world, where they're just working with Metro apps. So your startup apps in the desktop can continue to run. Let me give you a brief data point on this one. We went and purchased a few retail systems, and these are brand new systems. And we tried to find out what is the impact of those things. On average, we found about 30 startup apps. I'll define what startup apps mean. 30. And one of them had 49 of them. So you know how big the impact can get with so many of them trying to run. By startup apps, I'm defining them as anything that starts from the run key in the registry. I'm not including run once in that, because they run once and get away for the most part. And then there's the startup folder, which is under the start menu, the old start menu. So if you just look at those two, the run key from whether it's in the user hive of the registry or if it's in the machine hive of the registry, they will all run for that particular user. So I'm including both, and then the startup folders. If you include those, this is the scope of the work that we're looking at. And when we let the battery drain, for example, with the startup apps and without startup apps, the minimum gain in battery performance in one single charge was about 13%. And in some cases, we got up to 25% battery performance improvement. So that's a huge, so your 3 hours of battery life on one charge now became 4 hours. That's a significant change. So the key thing you have to think about is what is it that you're using the startup apps for? If you're notifying customers for something, then the Metro style design really provides a fantastic way of doing this. This is the Windows notification services. That's an absolutely fantastic way of changing your messaging to the user to use that. And if you're using it from a device context, there are new device APIs that actually provide these context-sensitive things that you can do. There are already extensions in the device stage, for example, where you can give context-sensitive information to the users if you want them to take action on that device that they're using it for. And remember that most of the time, startup apps are running all the time. Let me not say that. Let me change that. Most of the time, startup apps are running even though the user is not in the scenario that the app needs them for. So that's the key problem that you'll end up with. If you're doing maintenance tasks, such as updating your app, sending telemetry, and various other things, Windows 8 has a new feature called automatic maintenance. What automatic maintenance does is basically silent, headless maintenance mode, meaning the maintenance mode will come up when the user is idle, run a few tasks, finish all of the tasks, and go back to sleep, for example. So this runs on regular intervals, whether you want to run once a week or once a month or whatever your cadence is, you can do that. And you can do that without ever trying to disturb the user. If you want to keep your app always up to date, that's a fantastic way to do that. It'll just run, and you can update your app and be done with it. So I was going to show you a demo, but I think if you've seen the keynote, you've probably already seen what I was going to show you. So Windows introduces a new way to just simply turn it off. For those of you who have not seen it, let me just switch over and show you. So if you've seen the new Task Manager, there's a Startup tab. The Startup tab basically lists all of the apps, the exact same locations that I talked to you about. These locations are basically the run key and the startup folder. And it provides a lot of information around these startup apps. For example, it gives you the disk I/O, the CPU time, whether it's running, and various other information. So you can right-click and search the web if you don't know what it is, and potentially do some interesting things with that if you want to learn more about what this app does. And you can also simply disable them. And disable means it actually does disable it, meaning the disable mechanism is a little bit different, so it'll just work. So the app cannot go back and re-enable itself, so something to think about. Many apps, by the way, do that. They go back and try to re-enable themselves. So, all right. Finally, to close out this first section, let me talk about .NET 3.5. As part of an effort to basically reduce the disk size of Windows 8, we removed .NET 3.5 from the default install of Windows 8 because .NET 4.5 is already on the box. So let me explain what this change actually is. So if you're upgrading from Windows 7 to Windows 8, Windows 7 had 3.5. It's not, the upgrade does not remove it. It'll keep it. If you're an enterprise customer, then you probably don't have to worry about this particular thing because you will have .NET 3.5 packaged up as you can package it as part of your base image when you're deploying it to your thousands of customers, or if you do create images that way, then you don't have a problem with that. Only on a clean install of Windows 8, you won't get 3.5 by default. The first time an app requests 3.5, you will get something called Feature on Demand, which kicks in, which downloads 3.5 from Windows Update. And the other thing that we did was put this on Windows Update for a reason, because it'll be consistent from a distribution perspective as well, so that everybody gets a clean copy of 3.5, and they're always up to date. The key change from a developer perspective that you need to think about is, what does this do to your app? First of all, there is one extra layer of user experience that the user needs to go through. And second, connectivity becomes important. If it's not on the box, and if you're a clean install, and you don't have connectivity to the Windows Update, then your app might not be immediately usable till they're able to download it. Of course, the key thing to note is this is a one-time hit, meaning once the user downloads it and installs it on their machine, they're pretty much done. So they don't have to keep doing this again and again. From an action perspective, think about just using what's in the box, which is 4.5 right now, but 4.0 will work exactly as 4.5. And you can do more things if you want, like optionally check for connectivity, check for APIs for the new on-demand mechanism, and see if you want to go through that. But if you're using 4.5 on Windows 8, that shouldn't really be a problem. So I'll show you a quick example of what happens when you end up with a 3.5 app. I wrote up a sample app, which is just a dummy app which just tries to launch in .NET 3.5. Well, I launch it. As soon as I launch it, you get this thing called turn Windows features on or off. It's essentially saying, hey, you don't have 3.5, so download it from Windows Update. This one, by the way, even though it just says 3.5, it also gets you 2.0. So 3.5 package contains .NET 2.0 as well. So if you have any dependency on 2.0, you're covered with this one as well. So I'm going to cancel it out because it's going to take some time to install. So anyway, so what I'm trying to say here in closing out this is that 4.5 just works. Oh, I didn't show you 4.5. Let me go back and show that. So if you run the 4.5 app, there's no problem. It just runs out of the box. It doesn't depend on it, even though this was built with targeting a framework of 4.0. So that gives you an idea that moving it on to 4.5 is probably the best thing from an app perspective. So as you can see, the number of big decision changes, design changes, whatever you want to call them, are pretty thin in Windows 8. We have really tried to bake all kinds of compatibility stories right into the design so that you don't have to really deeply worry about concentrating on changing your app just to be compatible with Windows 8, for example. So with that said, I'm going to change topics and talk about some of the best practice principles for desktop apps. What do I mean by best practices? Here, basically, what I'm trying to focus on is as we go through our development cycle, we find a lot of unique failures with applications. These are not failures that happen because Windows design changed, but somehow either there was some oversight in the app of some sort, or in some cases, I'll show you, some of the design changes were 2-3 releases ago. Windows 2000, Windows XP changes that new apps still continue to fail on in some cases. So these are things that I'm just telling you, keep a watch out for, and make sure that as part of the team, take this message back to your team and make sure that you're aware of these kind of issues that you might face. First, hey, installers. We're still talking desktop apps, remember. This is your customer's first experience. And sometimes we've noticed that this gets the short end of the stick in many cases. That means that installers have to run in multiple privilege scenarios, low or high, admin privileges or standard users. Installers need to run in multiple architectures, 32 or 64-bit. So if you haven't really thought about all of those things, you can end up with some significant failures. So if you don't want to support it, that's fine. But make sure you check and fail gracefully. That's the key scenario you have to think about here. And the second one I'm going to talk about is repackaging. There's nothing wrong with repackaging Windows redistributables. There's a lot of Windows features that come through redistributables. But the key thing to remember is keep the package integrity as is. We have seen apps that crack open the package and ship only the 1 or 2 binaries that they care about, because that's the only dependency they want. When you do that, Windows recognizes that the integrity of the package is broken and it'll fail to install. That means there's potential that the entire app will fail to install. So these sound like simple things to think about, but we've seen a lot of failures for these kind of cases, where these are the kind of things where we cannot have a class kind of mitigation that fixes a whole bunch of apps. We have to fix these apps one by one by hand to get them to work on Windows 8. But in many cases, they do happen. Let's talk about using Windows resources. This is for the runtime of your app. I'll give you a small story. We just downloaded a brand new version of a brand new app. This is a top 100 app. I'm not going to name the app. I'm sure you can be curious. This thing is very popular, used by millions of users. We downloaded it 2 months ago. They released a new thing. And I talked to you about how we have detectors for compatibility in Windows 8, right? So as soon as we install this app, a couple of our detectors fired up. And we noticed that basically it's either a bug or they've missed the way they call system folders, for example. They're checking for Windows Media Player. They're checking if wmplayer.exe is on the box. And to do that, and they're using %program files % properly when they're trying to use it as a variable in their code. But when they actually try to access the file, they use the same path. They don't expand it back, for example. When you don't expand it back, obviously, it's going to fail. The app doesn't actually fail completely, but anytime they need to actually use WM Player to run anything, that particular scenario of the app is now gone. That app doesn't work for that particular case. So if they launch media using Windows Media Player for any media that they launch from within their app, that scenario is now completely broken. So now we basically go back to them. Since they just recently released it, we're going back, talking to them, asking them to fix it. So this sounds like a simple thing, but you'll see that top apps, new apps that just come out can also have these kind of issues. Using regexpand SE would have solved it. I'll show you an example of that later on. Registry, oh my God, this is one of those fun things that we have every time we see this. Somebody asked me earlier yesterday in the Ask the Expert session, is registry going away finally? No, it's not going away. So it's one of those kind of things, right? People use the registry in so many different ways. And people use it as a communication device, for example. Like one process puts something in, another process reads the same thing. So now you have an inter-process communication going on with some location in the registry. You make some changes. Windows makes a small change somewhere, and now that whole app is broken because of that. And there are configurations that you can set, Windows configurations that you can change and set. Apps go directly dig into that and change the value and say, I'm done. So these are the kind of things that can get apps into trouble, primarily. Because if you use the APIs to set and get configurations, for example, you don't have to worry about if that location in the registry changes at some point in the future. Your app won't fail. Your app is now resilient to those changes. These are very simple things that you can think about to make them really good. And then the third point there is OS binaries being hardened. Security is obviously a very important thing for the Windows ecosystem. We're always working on making sure that malware, it's harder and harder for malware to inject themselves into various scenarios. That means that there are genuine apps which do have, in many cases, important scenarios, but what they do is they try to patch the binaries, meaning either change the import address table of some of the Windows DLLs, or inject themselves so that they're running along with every Windows system process, things like that. Those are the kind of things which, because of all the hardening efforts, if your app is trying to do something like that, there's potential for failure for those kind of things. You have to watch out for those. The last one is very, sounds like absolute common sense, but we find this pretty significantly. APIs can introduce new error codes and new return values, and apps don't check for those. And in many cases, I've seen apps crash completely because they don't know how to handle the new error code that came back, or the new return value that came back. So have a way to handle unknown error codes. So that's a simple suggestion, but it goes a long way in making sure that your app's resiliency and reliability can be much higher than what you would end up with otherwise. Here's a quick example, right? Let me see if I can. This is an example, essentially, which shows you using the expansion. These guys, in this sample, basically they're trying to write to the Windows directory in the registry, Windows folder in the registry. And they're using, this is an example of how to do it the right way. They're using the right regexpand SZ function to make sure that the key and the subkey that they want to put in the registry is going to the right location. I want to clarify this. I just took this off of MSDM. I didn't go hunting for code anywhere. These kind of examples are available all over the place. So these are established public practices that are talked about all over the place, but something to think about when you're doing some of these app scenarios. The second one I'm talking about here is I just talked about API return codes. So I don't know how many of you know about the succeeded and failed macro that is available in C++. This is something you can use very easily to check for any result coming back from an API. If it's succeeded, then do this. Otherwise, do something else. That's all this function is doing, nothing more. But you'll find that there are many, many apps that they'll call an API. Hey, I'm done. The API is supposed to do its job. It did it. And I'll assume that it did its job and continue on. So the moment some new failure comes in, there goes your app. So something to think about. And finally, I'm going to talk about the last best practice for desktop apps. And this is manifesting your executable. Remember, this is nothing to do with Metro-style apps. This is not the Apex package manifest. This is the manifest that goes with your executable, exe, the Fusion manifest, if you know about Fusion. So what this is essentially, let me give you the value proposition of this. Manifesting your executable essentially ensures that you take control of your app. As simple as that. Meaning, if you don't manifest your app, Windows is going to try to figure out what is it that you're doing, what privilege you need, what compatibility mode you need, what scaling you need, and all of those things. And it will decide a heuristic and apply those to your app. Instead, by declaring it in your manifest, you're saying, no, give me what I want. This is exactly what I want. And now Windows is just going to not bother with any of these kind of heuristics. The first one is obviously privilege. And this is telling the app, this is telling the Windows what level of privilege you need. As invoker means you run a standard user. This is the default. If you don't declare anything in your manifest, this also used to be called the UAC manifest. This is actually the trust info in your XE manifest. So if you put your request level as invoker, that means that you're running as standard user. As explorer, when somebody double-clicks on an icon, this is what the default is. If your app must run as an administrator, then there's another setting called as administrator that you can use as well. So there's a lot more info that you can get on MSDN on what you can do with these settings and what's the right setting you need to apply to your app. And another thing that this also does is make sure that you don't get virtualized. Virtualization was a compatibility feature introduced in Windows Vista, essentially because apps written for XP would assume that you can write to anywhere on the system. Vista introduced the security model where program files and Windows folders were tightened down significantly, and only admin privileged apps could write to those locations. What they did with virtualization was every time an app tried to write to those locations, it would virtualize it and write to a user location, but the app wouldn't fail. The app thought it did the right job. And the virtualization driver would handle all of those things. But now, if you don't want that virtualization, make sure you declare this, you don't get any virtualization. That's one thing. Now let's talk about the compatibility section. Compatibility section is basically getting away from the compat heuristic. What the compatibility heuristic is basically trying to determine what the app is, when it was written, what is the right context it should run under. So this one essentially says, I know about Windows 8. Don't give me any compat modes. There are a whole, if you go to MSDN, there's an article, I'll point you to one later on. There's an article which tells you what are the APIs that use this compatibility section and give you different compat modes. So if you run in Windows 8, you get, so for example, a thread pool. There was a new thread pool introduced in Windows 7. So you get, that thread pool APIs are different between Vista and Windows 7. But if you don't declare this, you get the Vista behavior of the thread pooling. And in Windows 7 and Windows 8, if you declare the Windows 7 or 8 good, then you get the new behavior. So these are the kind of things you have to think about and basically take control of what behavior your app wants to run under. And finally, the DPI section. This is not new. This has been around for a while, but I want to reiterate this point. Windows introduced DPI, automatic DPI scaling in Windows 7. And what this does is, in higher DPIs, if you don't have either this tag or if you haven't provided the right resources, Windows will try to scale it and make your JPEG much bigger. Obviously, the pixelation will go crazy at some point. So think about it from that perspective. If you put DPI aware if it is equal to true, then Windows will not scale your resources. It also means that you have to do some amount of extra work to provide the right resources for the right DPI. So that's the extra you have to think about. All right, we've now talked about a lot of things for compatibility, changes in Windows 8, some of the best practices. And now let's close out the desktop section by talking about certification. I don't know how many of you know, there's a hands-on lab in Hall D. You can go, if you have your app, they'll help you debug it and see if there are any issues, if there are any issues. And they'll help you walk you through the certification process. So if you get a chance today, you can go kind of work that through. So formerly, the Windows Software Logo Kit, if anybody knew about that. We got a good amount of logoed apps in Windows 7. We hope to get more. Why? Anything that gets logoed or certified in Windows 8 will automatically go to the Windows 7 or Windows 8 Compatibility Center. Windows 8 Compatibility Center, as I told you, is one of the most popular sites that we've had. We get more than 3 million unique users per month. And these are users who either are about to purchase or have purchased Windows 7, and they're looking for compatibility of their apps. And having the Windows logo with your app obviously means that there's more trust in that. So the moment you get certified, your app automatically gets listed in the Windows Compatibility Center. Obviously, getting your app certified is one of the requirements to list your desktop app in the Windows Store. If you haven't seen any of the Windows Store topics, Ted Dworkin from the Windows Store team gave an introduction to Windows Store talk a couple of days ago. So you can definitely watch it online and get yourself more familiar with all the things that you need to prepare for getting your app to the store. So something to really be watching out for. Let me just give you a brief look at what certification looks like. For those of you who don't know, the Windows App Cert Kit, the icon is right on the front page. And that Windows App Certification Kit icon, this one, is the same kit used for desktop apps and for Metro-style apps for validation of your apps. So I'm going to choose a desktop app. It's pretty straightforward. It's just a couple of wizard-like UI. You can point to your installer, choose whether it's a per machine or a per user setting for your app, and run through it. It's going to take about 4 or 5 minutes. I'm not going to kick this off. I'm just introducing you. It does a lot of checks, such as it does some basic checks, whether you do an OS version check, for example. It does some of the best practices checks that we talked about. It also checks for some of the manifests that we talked about, whether you declare things in the manifest. And it does some basic reliability and security checks as well. Well, after all of those things, it gives you a pretty straightforward and simple report. And I'm going to show you one right now. Essentially, this report is saying, hey, your app passed, but with warnings. Warnings means, essentially, there are some things which actually don't fail your app, but there's an opportunity for improvement. There are things like, say, performance. We noticed some performance lag in some areas, some scenarios, that there's opportunity for improvement, for example. If you put an entry in the add remove programs, I've seen apps put their file location as C:. So obviously, that can be a problem. So those are things that you can think about. Walk through this. It doesn't take more than 15 minutes of your time to walk through a whole lot of things. It just shows you all the tests that it goes through, and it gives you either a pass rating, a fail rating, or a warning, which says a warning is basically it passed, but there's room for improvement in some areas. And I'll show you a fail rating. A fail is essentially something which says your app doesn't install. Your app doesn't uninstall, for example. That'll fail your app. It's as simple as that. So if your app uninstalls cleanly, then you don't have to worry about this. Obviously, this was run on a demo mock-up app just on purpose to fail this. So, all right, kind of gives you an idea of the certification process. And let's talk about some things for Metro-style apps. So earlier, I gave you some information about the version check problem, some information about that. So one of the things that we wanted to do is, this is a brand new opportunity that we want to take and at least remove that one significant problem from the picture. So there are two things that we did. One, we turned the tables a little bit around on that one. And what I mean by that is that apps don't actually ask for the version anymore. Apps will just declare what they want. So in your Apex manifest, you just declare what is the minimum version that you want in your app. So obviously, it's 6.2 for all Metro-style apps right now, because this is the first version of Windows that will support Metro-style apps. But think about it for the future. If you want to support an app where a particular API is only available in some future version of Windows, you can say, don't install me on 6.2. Install me only on 6. Whatever future number that could possibly be. So that way, Windows respects that and says, OK, you want Windows 8 plus, not Windows 8. So the store respects that, and the Windows deployment engine respects that and won't install it on your machine, on a Win8 machine, for example. Similarly, the OS Max tested version, OS Max version tested. What this says is, this is the version that I know I tested my app on and works great. This doesn't mean this is a high version bound. This doesn't mean that the Windows will prevent your app from installing if the version of the Windows it's installing on is higher than that. It just means that it manages the best compatibility behavior for that. Now, it is the declarative statement from your app that says, I know exactly what I worked on. Give me only this one. That's what you're saying, essentially. And Windows will basically provide that compatibility behavior for you. That's the key change. How do you declare it? You don't really have to worry about it for Windows 8, because Visual Studio Express will just simply stamp this in your Apex manifest when you build it. It'll just put 6.2 for both of them. So why do we need them now? This provides a good baseline for all Metro-style apps. So it's actually, both of these fields are actually required fields. So your app will not pass through the certification or store onboarding if you don't have these fields filled out. But you don't have to worry about it right now, because it's automatically filled out for you. So assessing your Metro-style app. What do I mean by that? Again, this is something very similar to what we already talked about, which is the app certification kit. The app certification kit, the key thing you need to remember here is a one-to-one match of the technical tests that we do. That means you have the tests that we check in the app certification kit are the exact same tests that the store will do when you submit your apps for listing in the store. This is for Metro-style apps. So this is the technical portion is exactly the same. There are more tests which are beyond this, but the technical portion will be exactly the same. So you know you've gone through your first set of tests to pass through. That's the key thing you can think about. It tests for various things, such as basically manifest compliance. By manifest compliance, with Visual Studio Express, you probably don't have to worry about any of these things, because most of them are already built into Visual Studio to make sure that you don't have any compliance failures. But if you're hand using your manifest, then you have to think about all of the different fields that are required, and you have to fill them out. So this is basically going through all of that. And then it does the DPI, image scaling and sizing. This is something that it checks across the board. Then platform-supported APIs, WinRT APIs, the SDK for modern apps, Metro-style apps are the only ones that are actually supported for Metro-style apps. So you cannot call, for example, a Win32 create file directly from a Metro-style app. So there's a set of whitelist, blacklist APIs, and it verifies that your app is only using the approved APIs list. And then there are some basic reliability and security tests that the certification does. Once it goes through all of that, you get a similar pass-fail report, and you can go through and submit your app at that time for the store, whenever the store opens up. So that kind of gives you a background on various different things that we are, the three big topics that we talked about. In summary, basically, for desktop apps, think about the big changes that we made. Your existing apps will continue to work, but as a developer, you have to think about taking advantage of the new changes that we made to make sure that your apps can continue to work in the future. Next, certify it. That's your clean path to both the Windows Store and the Windows Compatibility Center. And finally, for Metro-style apps, essentially, it's more of an awareness, making sure that you can, you know how you can use the OS version for Metro-style apps. One of the things that you can think about from a Metro-style apps perspective is also that by declaring the OS versions, you also get to light up on various different scenarios. So suppose you have Windows 8, 8 Plus, and 8 Plus Plus, some 3 versions of Windows in the future. Using these tags, you can make sure that you have proper light-up behavior. And that proper light-up behavior ensures that you have a single code base where you can do all of those things. You don't have to release different versions of your app for different versions of the store or different versions of Windows for each of the stores, for example. So these are things that you can really take advantage of. And think about them now while you're starting to design your Metro-style apps. That's the key point. So call to action, I think I've already mentioned this a little bit. There are hands-on labs that you can still use them today. They're open till 3 o'clock. If you have your apps, take them. They'll walk you through certification. And for Metro-style apps, again, there's another the self-directed lab where you can take your Metro-style app. If you've done a sample app or they have a sample app there, you can just walk through those and make sure you can get an understanding of what the store certification process will be. So these are the 3 things that I just talked about. And in closing, some further reading. The Application Compatibility Cookbook is online now. This is going to be updated for every release, meaning for beta, RC, RTM. We're going to keep updating them and completing them with various topics that we've discovered along the way. Obviously, any feedback that you send, any telemetry that we collect, all of that is going to feed into that. And learn about the Compatibility Center. You can see what the advantages are there once you list them. So that's your path for the desktop apps. And finally, thank you very much for being a great audience. And the forums are a really good place for asking questions. May not be now, maybe 2 months from now you have questions. We'll still be watching. So we're all going through that. So any kind of questions, you can ask it, and we'll be there to answer them. All right? Thank you.